Good morning, good afternoon, or good evening. This is Dr. Nak, and we're going to go over section 8.5, Sum and Difference Formulas. So I've already wrote down what we need to memorize. So we're going to be talking about cosine of alpha plus or minus beta, sine of alpha plus or minus beta, and tangent of alpha plus or minus beta. And the bottom two, we have gone over that before, but I wrote it down because we will be using these formulas quite often. Feel free to pause the video and write down all these formulas on your note cards or separate sheet of paper so that you can memorize them all. Let's do some examples. Example 1, find the exact value. And we're going to do part A, a sine of 105 degrees. Now on the right hand side, I'm not quite sure which way you like to memorize all the angles. So I have the chart above and then I got the triangles in below. But anyway, so let's get started on this one. So if I want to use the sum and difference formula, first I need to break down 105 into either the sum of two angles that you know or the difference of the two angles that you know. Okay, so let me see. So do you see that 105 degrees? Can be written as, let me see, 45 plus 60. All right, so it looks like we're gonna be using sine of alpha plus beta for this particular problem. So let me just write down the formula. Let me see, so you got sine of alpha plus beta. This is sine of alpha, cosine of beta, and then plus cosine of alpha and sine of beta. Okay, we're gonna follow that formula. So let's try to do this. I'm just gonna bring it over here. So sine of 105 degrees is the same thing as sine of 45 degrees plus 60 degrees. So 45 degrees is gonna become your alpha, and your beta is going to become your 60-degree angle. All right, so let's follow the formula. So this is going to be sine of 45, cosine 60, and then plus cosine of 45, and I'm running out of room, and sine of 60. Okay, so now let's compute each single one of them. Now sine of 45 degrees is root 2 over 2. Cosine of 60 degrees is 1/2 plus cosine of 45. Oops, why did I put 3 there? Sorry, I meant to write 2. And sine of 60 is root 3 over 2. Okay, so let's simplify. So you're going to have root 2 over 4 plus root 6 over 4. So the answer is going to be root 2 plus root 6 whole thing over 4. So here's our answer. Let's look at the next one. So let's call this one B. Tangent of 19 pi over 12. Okay, now let's bring the 19 pi over 12 on the side and let's just work it on the side. 19 pi over 12. Somehow we're going to have to break this down to familiar angles. So how about this? 16 pi over 12 plus 3 pi over 12. That would give us 19 pi over 12. Now if I reduce 16 pi over 12, we get 4 pi over 3, which is familiar to us, and plus pi over 4. So I think we're good to go. So we're going to be using these two angles. Okay, now let's write down the formula. So it looks like we're going to have be using tangent of alpha plus beta formula. So this is tan of alpha plus tan of beta, whole thing over, what is 1 minus tan alpha, and then tan of beta. Okay, so we're going to plug them in. so this is going to be tangent of, oh, you know what, let me just first rewrite like this, tangent of 4 pi over 3 plus pi over 4. So our first angle is, pretend this is your alpha. Now this is going to become your beta. Okay, so let's follow the formula. So what we're going to get is what? Tan of 4 pi over 3 plus tan of pi over 4. Whole thing over 1 minus tan of 4 pi over 3 and tan of pi over 4. To compute the tan of 4 pi over 3, let me just jot down where that 4 pi over 3 is going to lie in which quadrant. So all students take calculus. Alright, so 4 pi over 3 would be, where would that be? Around here. Oops, sorry, so this is 4 pi over 3. Now, tangent is positive in quadrant 3. So let me just write it. 4 pi over 3 is in quad 3, and tan of theta is positive in there. So therefore, tangent of 4 pi over 3 is same thing as its reference angle, tangent of pi over 3. Tangent of pi over 3 is sine of pi over 3 over the cosine of pi over 3, so this is square root of 3. Okay, so now let's plug it in. So tangent of 4 pi over 3 is square root of 3 plus tangent of pi over 4 is 1. Whole thing dividing by 1 minus root 3 times 1. I don't know why I put the parentheses there. So this is going to be root 3 plus 1 over 1 minus square root of 3. Always rationalize your denominator. So what we need to do is multiply the top and the bottom by the conjugate of the denominator, which is 1 plus root 3. Multiply that out. What do we get here? Square root of 3 plus 3 plus 1 plus square root of 3, whole thing over 1 minus 3. Okay, so I'm just going this side. So this is same thing as 2 root 3 plus 4 over minus 2. So let's see, you can divide it by 2 on every single one of them. So then what we're going to get is square root of 3 plus 2 all over negative 1. Or that's exactly the same thing as negative square root of 3 minus 2. So that's going to be our answer. Let's do another example. So let's call this one C. Cotangent of negative 5 pi over 12. So pause the video for a little bit and try to see if you can do this on your own. Okay, now I'm going to pretend that you did it on your own. So let's first break down 5 pi over 12 and we'll throw the negative at the end. So let's go with 5 pi over 12. How did you guys break it down? So what I did was I could go 8 pi over 12 minus 3 pi over 12. So that will give us 5 pi over 12. But if I simplify it, I'm going to have 2 pi over 3 and then minus pi over 4. Okay, so that implies that negative 5 pi over 12 is same thing as negative of 2 pi over 3 minus pi over 4. This is just one way to do it. So it looks like what we're going to get is, let me just rewrite the positive one first, pi over 4 and then minus 2 pi over 3. So this is how I broke it down. Okay, so let's take a look. So first, cotangent is 1 over tangent. Okay, but this is same thing as 1 over tangent of pi over 4 minus 2 pi over 3. Okay, so now we're looking at the formula tangent of alpha minus beta, which is tan of alpha minus tan of beta all over 1 plus tan alpha tan beta. Okay, so this is going to equal to 1 over, so it's going to look a little bit ugly here. So we get tangent of pi over 4 minus tangent of 2 pi over 3. And now whole thing over 1 plus tan of pi over 4 and tan of 2 pi over 3. Okay, so now let's just keep on going here. So we have 1 all over. Now tangent of pi over 4 is 1, so we're going to have 1 minus. Now let's go with the tangent of 2 pi over 3. So let me just jot down where the 2 pi over 3 is going to lie in which quadrant. Alright, now 2 pi over 3 lies in quadrant 2. Now, we're talking about the tangent, so in quad 2, tangent of theta is negative. Alright, so therefore, tangent of 2 pi over 3, this is going to be negative tangent of, its reference angle is just pi over 3, which gives negative square root of 3. Okay, so I think we're good to go. So we have 1 all over 1 minus square root of 3, whole thing over 1 plus 1 times negative square root of 3. I hope you can follow my work okay. So let me just keep going. So this is 1 all over. Here you're going to get 1 plus square root of 3 over 1 minus square root of 3. So we have it 1 over that whole thing, so we should have 1 minus root 3 whole thing over 1 plus square root of 3. Okay, now we need to rationalize the denominator, so we multiply by the conjugate of the denominator, which is 1 minus square root of 3. Okay, so then what do we get here? So this is going to look like, what is that? 1 minus square root of 3 minus square root of 3 plus 3. If you can hear that beep, I'm sorry, that's just my rice maker. My rice is done. Alright, now whole thing over 1 minus 3. Okay, so then this is going to equal to what? 4. Oops, sorry about that. 4 minus 2 root 3 whole thing over minus 2. Now 2 is going to go into every single one of them, so dividing out by negative 2 to each term, looks like we're going to have, this is going to be negative 2 plus square root of 3. And here we go. That's our answer. Okay, so let's just call this one a different example. So I'm going to call it example 2, find the exact value. Okay, so let's go with part A. How about cosine of 40 degrees and cosine of 10 degrees plus sine of 40 times cosine of, oops, sorry, cosine, cosine, sine, sine, that's what I meant to write. Sine of 10 degrees. Now we have cosine, cosine plus sine, sine. So that is the formula for cosine of alpha minus beta. Let me just rewrite the formula. So because this is equaling to what? Cosine of alpha, cosine beta, and plus sine alpha, sine beta. Oh, sorry. Okay, so basically then, this whole equation was nothing but cosine of 40 degrees minus 10 degrees in this, guys. Alright, so this is nothing but cosine of 30 degrees which is same thing as cosine of pi over 6, which is root 3 over 2. And that's our answer. Okay, so let's do another example. So we have sine of pi over 18, cosine of 5 pi over 18 plus cosine of pi over 18 times sine of 5 pi over 18. So again, pause the video for a little bit, and your job is to pick and choose which formula that you're going to apply for this particular problem. Okay. Have you chosen your formula? So what do we have here? Sine, cosine plus cosine sine. So that looks like what? We're going to have sine of alpha plus beta. Did you choose that one? Okay, so let's do this then. So this is nothing but sine of pi over 18 plus 5 pi over 18, which is sine of 6 pi over 18, which is what? Sine of reduce that, and what do we get? Pi over 3, which is square root of 3 over 2. So there you go. Okay, so now let's look at the next example. Let's do something a little bit different. Little thinking is required for this problem. So let's go. Given that cosine of beta is 2 root 5 over 5, where beta is between negative pi over 2 and 0, and that's an and sign. Sine of alpha is given by 3 over 5, and alpha is between 0 to pi over 2. Alright, so part A, find sine of alpha plus beta. So the formula for sine of alpha plus beta, let's just write that out. So this is sine alpha cosine beta plus cosine of alpha and sine of beta. Okay, so this is what we need to compute. So we are given cosine beta and sine of alpha. We're given that. However, we don't know the values for cosine of alpha and sine of beta. So let's draw out the picture and see what's going on. Okay, so all student take calculus. All right, so let's look at the cosine of beta. Now cosine of beta, first of all, beta is between negative pi over 2 to 0. So here's our negative pi over 2, and here is our 0. So our angle beta lie in quadrant 4. Now the cosine is what? Adjacent over the hypotenuse. So let me draw that triangle. Oh my goodness, please pretend that's a 90-degree triangle. So this angle right here is our beta, and the length are 2 root 5 adjacent over height, so the hypotenuse is 5, and so that means what? The missing length should be square root of 5. Okay, so let me just put the big dot right there. Now this point right here is 2 root 5 when x is 2 root 5 and y is negative square root of 5. Oh, why did I just put 3? Sorry. Okay, keep that in mind. So that's our angle beta. Now let's jot down the alpha, angle alpha. Now alpha better be between where to where? 0 to pi over 2. So 0 to pi over 2. So alpha must lie in quadrant 1. So let me draw that triangle real quick. Should I change the color? I think you guys can follow it. So let me just draw a different triangle. I hope you can see this. Okay, and so let me see. Our length is what? Sine of alpha is 3/5, so it's the opposite side of the angle alpha. By the way, our angle alpha is right here. Can you tell? All right, so opposite over the hypotenuse, so the opposite side of alpha has length 3, hypotenuse has length 5. So that means the base for this triangle is going to be what? 4? Okay, so with that said, I am so sorry, you guys. Can you see this okay? I'll be more than happy to redo this for you if you cannot read my handwriting or cannot follow it through. But anyways, this point right here is, what is that? X is 4 and Y is 3. Okay, so keep that in mind and let's do this. So sine of alpha is given by 3/5. That's given to us. And cosine of beta is 2/5/5. That's also given to us. Now, what we need to do now is compute the cosine of alpha. Okay, so let's look at the top triangle. Cosine is adjacent over the hypotenuse of that triangle. So the adjacent side is 4, hypotenuse is 5. So that's the value of cosine alpha. Now sine of beta, sine is opposite over the hypotenuse, or you can think of it in terms of y/r. So here what we're going to get is -√5/5. Okay, so all we have to do is simplify. Let's just bring it over here. So what do we get? 6√5/25, and then minus 4√5/25, which gives 2√5/25. And we cannot simplify any further, so this is our answer. Let's do another one. Call this one B. So try this one on your own. Cosine of alpha plus beta. We're still talking about the same alpha and same beta. So pause this video and try this on your own. Okay, how did you guys do? So first, let's write down the formula that we need. So cosine of alpha plus beta is cosine alpha, cosine beta, and then minus sine alpha, sine beta. Okay, so what's cosine of alpha? 4/5. Cosine of beta is 2√5/5. Minus sine alpha is 3/5. And sine of beta is -√5/5. So what do we get here? So we're going to have 8√5/25 and plus 3√5/25. So did you all get 11√5/25 for the answer? Or did I do this wrong? I think this is right. So here we go. I hope you did this one okay. If you have any questions about this, please let me know. Let's do another example. So let's call this one part C. We're going to be doing the same thing. So let's go with tangent of alpha minus beta. Again, feel free to pause the video. So tan of alpha minus beta is tan alpha minus tan beta, whole thing over 1 plus tan alpha and tan beta. Okay, so this is same thing as 3/4 minus (√5/2√5). because tangent is opposite over adjacent. And this whole thing over 1 plus 3 over 4 and negative root 5 over 2 root 5. Okay, looks ugly, but let's simplify a little bit. So this is 3/4 now plus, I could cancel the root 5 on the top and the bottom, so this is just going to become 1/2. Whole thing over 1 plus 3 over 4, and this is going to become negative 1/2. So this is 3 over 4 plus 1/2. Whole thing over 1 minus, what is this, 3 over 8, which is 5/4 over 5/8, which is 5 over 4. Dividing by 5 over 8 is same thing as multiplying by this. So it looks like our answer is 2. How did you guys do on this one? Hopefully you did okay, and hopefully you're kind of getting hang of it. Good job, by the way. Let's take a look at another example. Let's do something different. So example 4. If cosine of theta is 1/4, theta is in quadrant 4, find, let's do a few examples here. Find a sine of theta. So first, let's draw the picture. And it must lie in quadrant 4. So cosine is, if you want to think of in terms of a triangle, it's adjacent over the hypotenuse. Or if you want to think of it in terms of x, y, and r, cosine is x over r. So our x value is going to be 1, or the adjacent side of the angle is going to be 1. And the hypotenuse, or the r, is going to be 4. So this length is what? Let me just compute this real quick. A squared plus 1 squared equals to 4 squared. So a is square root of 16 minus 1, so it's square root of 15. So this length is square root of 15. Alright, so this point right here, let me change the color so you can see it better. So this point right here is 1 comma negative square root of 15. And before I forget, this is our angle theta. Okay, so let's do this now. I think we're good to go. Now those of you who like to solve this by using a triangle, notice that angle theta lies in quadrant 4. That means sine value is going to be negative. So no matter what, your answer is going to be negative. And negative what? So just stare at the triangle. It's opposite side of the angle theta over the hypotenuse. So here you're going to have square root of 15 over 4. So the answer is going to be negative root 15 over 4. Now, if you use x, y, and r, sine is y over x. Let me just write it out. I don't know which way you like better, so that's why I'm doing it in both ways. So also sine of theta is y over r. So again, our y is negative square root of 15 and r is 4. So we're going to get the same answer. Just wanted to show you that. So choose your favorite weapon. I don't care if you want to do it by the triangle or the x, y, and r. Alright, let's take a look at the next one then. Part B, sine of theta minus pi over 6. Okay, so let's look at this for a little bit. What can we do? So we have sine of theta minus pi over 6. So maybe we can apply sine of alpha minus beta formula. So which will be sine of theta and cosine of pi over 6. And this should be minus sine of pi over 6 and then cosine of theta. Whoops, there you go. Alright, so let's compute this out. So first of all, sine of theta is negative square root of 15 over 4. And cosine of pi over 6 is root 3 over 2. And minus sine of pi over 6 is 1/2. And cosine of theta is 1/4. So multiply this out, then what do we get? Negative, let me see, what is that? 3 root 5 over 8. And then minus 1 over 8, which is negative 3 root 5 minus 1 whole thing over 8. And this is going to be our answer. Okay, now let's do another example. Let's bring on the tangent. So try this on your own and see what you're gonna get. You might have to scroll back to the previous page or rewind the video just to see that the triangle. And why am I pausing? Okay, so I'm just gonna pretend that you just paused it, and I'm just gonna start doing this problem. So first, I'm going to apply the formula tan of theta minus tan of pi over 4 whole thing over 1 plus tan theta and tan of pi over 4. Okay, so looks like this is going to be tangent of theta is negative root 15 over 1, and minus tangent of pi over 4 is 1, whole thing over 1 plus negative root 15 times 1. Okay, so then let's just bring it over here. So it looks like we're gonna have root 15 minus root 15 minus 1 over 1 minus root 15. Okay, so now we're gonna have to rationalize this. Okay, now multiply it out, then we get negative root 15, and then what is that, minus 15, and minus 1, and minus square root of 15, whole thing over 1 minus 15. Okay, so let's combine, then what do we get? Negative 2 root 15 minus 16, whole thing over negative 14. I think 2 is going to go into 2 and a 14 and a 16, so dividing out by 2's, we're going to get negative root 15 minus 8, the whole thing over minus 7, too many minuses. So here, think of it in this way, factor out the minus from the numerator, then you're going to have this over minus 7. So negative over negative makes it into a positive, so our answer is going to be root 15 plus 8 and whole thing over 7. How did you guys do on this one? Hopefully you did okay. And let me know if you have any questions, of course. Okay, so now let's try some identities, establishing the identities. So switching it up a little bit. All right, so let's take a look at A. Cosine of pi over 2 plus theta equals negative sine of theta. So again, you're going to have to choose either left-hand side or the right-hand side. So I'm just going to go with the left-hand side. Okay, so left-hand side equals, always write down the problem again, cosine of pi over 2 plus theta. Okay, so I think we should apply the cosine of alpha plus beta formula. So this is going to be cosine of pi over 2. And then cosine of theta. And this is going to be minus sine pi over 2. And sine of theta. Okay, so then what's cosine of pi over 2? Cosine of pi over 2 is 0. 0 times cosine of theta. And minus sine of pi over 2 is 1 times sine of theta. So this is going to get what? 0 minus sine of theta, which is just minus sine of theta, which is precisely our right-hand side. Okay, so let's do another one. So part B, tangent of 2 pi minus theta equals negative tan of theta. So use the similar trick that we just did and pause the video and please try this on your own. Okay, so first I need to pick and choose, so I'm going to choose the left hand side. Okay, so let's use the formula of tangent of alpha minus beta, which is tan of 2 pi minus tan of theta, whole thing over 1 plus tangent of 2 pi, and then tangent of theta. Okay, so note that tangent of 2 pi is same thing as sine of 2 pi over cosine 2 pi. But sine of 2 pi is 0 and cosine of pi over cosine of 2 pi is 1. So tangent of 2 pi should give us 0. So this is same thing as 0 minus tan of theta all over 1 plus 0 times the tan of theta. So here you're going to have negative tangent of theta, whole thing over 1 plus 0, which is just negative tangent of theta. This is exactly what we wanted to prove. Let's do another one. How about sine of alpha plus beta, whole thing over cosine alpha and cosine beta equals tan alpha plus tan beta. Again, feel free to stop this and you can try this on your own. Okay, I'm going to start from the left hand side. So what should we do? So let's first apply the formula for sine of alpha plus beta, which gives us sine of alpha cosine of beta plus cosine of alpha and sine of beta, whole thing over cosine alpha and cosine of beta. All right, now what? Okay, so it looks like we have this going on, a plus b over c. This is a over c plus b over c. Okay, let's separate them. So this is sine alpha cosine beta over cosine alpha cosine beta plus this all right. So now what can we do? Okay, well, look at that. We can kill the cosine of beta and kill the cosine of alpha. So what do we got left? We have sine of alpha over cosine alpha plus sine beta over cosine beta. But sine over cosine alpha is tangent of alpha, and plus this one is going to be tangent of beta, which is exactly what we wanted to prove, so we're done. Okay, now let's look at the next one. Cotangent of alpha minus beta equals cotangent alpha cotangent beta plus 1 all over cotangent beta minus cotangent alpha. So try this one on your own again, and don't get frustrated. Okay, so I'm going to pretend that you paused it, and let's do this. Which way did you guys start? Right hand side or the left hand side? Right hand side looks more complicated, but what I'm going to do is I'm going to start working from the left hand side, because I know that cotangent is 1 over tangent, so I can maybe use the formula for tangent of alpha minus beta to it, and I'm just going to see where that's going to take me, or us I should say. Okay, so let me underline which side I'm going to be choosing. Okay, so make sure to work this step by step by step. So cotangent of alpha minus beta is same thing as 1 over tangent of alpha minus beta, okay, which is same thing as 1 all over tan alpha minus tan beta, whole thing over 1 plus tan alpha tan beta. Now, which is same thing as, let me just bring it over here, 1 plus tan alpha tan beta, it's going to go in the numerator. Now whole thing over tan alpha minus tan beta. Okay, so I'm just going to take a look at what we're trying to prove. If I want to show the right hand side, I need cotangent to appear. So how about this? Let's convert tangent in terms of 1 over cotangent and see where that's going to take us. So first, let me just do it this way. So here you're going to have 1 plus 1 over cotangent of alpha times 1 over cotangent of beta, whole thing dividing by 1 over cotangent of alpha minus 1 over cotangent of beta. Okay, just to keep it organized, let me just color code it. So I'm going to simplify the numerator, just going to circle that in blue, and separately from the denominator. Okay, so I'll write the numerator, simplified version of the numerator in blue, and denominator in lavender color. But anyway, so let's do this. Okay, so I'm going to keep the big fraction bar over here. Now let's deal with the numerator. So what I like to do is combine those two expressions. So the common denominator will be cotangent of alpha times cotangent of beta. So here I need to rewrite 1 in terms of, oops, not cosine, sorry about that, cotangent of alpha, cotangent of beta over cotangent of alpha, cotangent of beta. So do you see that this is 1? And then plus 1 over, I'm going to multiply the two expressions. So you're going to have cotangent of alpha and cotangent of beta. All right, and then denominator, we're going to do the same thing. So the LCD, or the common denominator, is cotangent alpha, cotangent beta. So let me see here, if I need cotangent of alpha, cotangent of beta, I need to multiply the top by cotangent of beta, and then plus, oh, not plus, sorry, minus. Oops, where's my eraser? All right, so where was I? So cotangent beta over cotangent alpha, cotangent beta, and then minus. So here I need to multiply by cotangent of alpha. Okay, so we're good to go. So let's put this together nicely. Okay, so the numerator looks like we're gonna have cotangent of alpha, cotangent of beta plus 1, whole thing over cotangent of alpha, cotangent of beta, and whole thing over cotangent beta minus cotangent of alpha, whole thing over cotangent of alpha, cotangent of beta. Are you guys with me so far? All right, so now I'm going to simplify this. So here what we're going to get is cotangent of alpha, cotangent of beta, plus 1, whole thing over, sorry, that's a beta, and dividing by the denominator, you multiply by its reciprocal, so here you're going to have I hope you can follow this, follow my work okay. I apologize if you can't follow it. All right, so now what can we do? We can cancel out the cotangent of alpha, cotangent of beta. So kill. And looks like, oh, look, we're done. That's precisely the right-hand side now, isn't it? Awesome. So here you're gonna have cotangent of alpha, cotangent of beta, plus 1. Whole thing over cotangent beta minus cotangent of alpha, which is precisely our right hand side. Yes, we did it. Good job, you guys. Okay, our next topic is finding the exact values of composition of trig functions. So what I did here was I wrote down all the composition's properties involving sine, cosine, tangent, secant, cosecant, and cotangent. We have learned this in previous sections, but please keep this in mind while we go over some examples. Let's take a look at example 6. Find the exact value of that. Okay, so first, let's consider sine inverse of negative 4/5 to be alpha, and think of this as our beta. So this is of the form, let me just try to squeeze this in, sine of alpha minus beta, which is sine of alpha cosine beta minus cosine of alpha sine of beta. So what we're going to get here is sine of sine inverse of negative 4/5 and cosine of beta, which will be tan inverse of 3/4, and minus cosine of alpha, which is cosine of sine inverse of negative 4/5, and then sine of beta. Oh, I'm running out of room. Okay, so it looks like we're gonna have to compute this one first. Alright, so guess what? One problem turned into 4 problems. Okay, so as a side work, let's work these problems out separately. Alright, so this is gonna be our side work. So let's first go with circle 1. Sine of sine inverse of negative 4/5. Alright, so note that sine of sine inverse of x equals to x if x is between -1 and 1. So in this case, -4/5 is inside of -1 to 1. So this one was pretty straightforward. So therefore, this is going to be -4/5. Okay, so let's go to the next one. So let's call this one side work for 2. So what do we have? Cosine of tangent inverse of 3/4. All right, so I'm going to start out with, let theta be tan inverse of 3/4. So that means that tan of theta is 3/4. Now, provided that theta is between -π/2 to π/2. Let's draw out the picture and see what's going on. Alright, so since tangent is positive 3/4, that means better lie either in quad 1 or in quad 3. But since your theta must be from -π/2 to π/2, do you see that the quadrant 3 is going to be out? Alright, so our angle theta is going to lie in quadrant 1. Now, so those of you who like to use the triangle, think of tangent, think of tangent as opposite over adjacent. Or if you like x and a y and a r, this is y over x. Not sure which one you want to use, so either way is okay. So basically what's going to happen is, so this side is going to be 3, 4, and a 5. And here is our angle theta. Therefore, cosine of tan inverse of 3/4 is cosine of theta, because we're letting theta be tan inverse of 3/4. So let's look at that triangle. Now, cosine of that triangle is adjacent side over the hypotenuse. So that will be 4/5. Or if you want to think of in terms of x, y, and r, cosine is y over r. So it makes sense. All right, so I'm going to box that for the answer. Okay, so let's go with side work for 3. 3 is cosine of sine inverse of -4/5. Okay, now we're going to do the same thing as what we did earlier. So first, let theta be sine inverse of -4/5. So that implies that sine of theta is -4/5. And here's the important part. Theta is between -π/2 to π/2. So again, let's draw a picture to see what's going on. Okay, so in this case, our sine value is negative because we have a -4/5. So sine is negative in quad 3 and quadrant 4. But theta better be between -π/2 to π/2. And so that means what? Quad 3 is out. So your angle theta is going to lie inside of quadrant 4. Okay, so again, those of you who likes the triangle, sine is opposite over hypotenuse, and if you like x, y, and r, sine is x over r. So here, regardless, you're gonna get this triangle. This is completely drawn off the scale. I apologize. So this is sine opposite. Hypotenuse is 5, so that means the remaining is 3. So this is our angle theta that we're talking about. So again, this point right here is x is 3 and y is -4. All right, so I think we're good to go. So therefore, cosine of sine inverse of -4/5 is cosine of theta. Now, cosine of theta is adjacent over hypotenuse of that triangle, and the value should be positive because cosine is positive in quadrant 4. So in this case, what we're going to get is what? Adjacent side over hypotenuse. Or you can think of it as x over r. So it's still gonna be 3 over 5. So we're done with side work for 3. Phew. All right, one more. So let's go with side work for circle 4. What do we got? Sine of tan inverse of 3 over 4. Okay. Let theta be tan inverse of 3/4. Oops. So that implies that tan of theta equals 3 over 4. Okay, so picture time. Okay, so since tangent is positive 3 over 4, tangent is positive in quadrant 1 or quadrant 3, but it has to be between -pi/2 to pi/2. So again, quad 3 is out. So our angle theta is going to lie in quadrant 1. So tangent is opposite over adjacent. So let me just draw a triangle. So this is our angle theta. So the length here is 3 and a 4. That means what? This side better be 5. So those of you who likes to use x, y, and r, this point is what? X is 4 and y is 3. Okay, keep that in mind and let's go. So therefore, sine of tan inverse of 3 over 4 is sine of theta. Now sine is also positive in quadrant 1, so your answer should be positive. And sine of theta is opposite over hypotenuse, so 3/5. Or you can think of it as y over r. It's going to give you the same value. So here we go. Okay, so now finally we get to put this together. So therefore our final answer is going to be circle 1. Where in the heck is circle 1? Circle 1, well, -4/5. And circle 2 is 4 over 5. And minus 3/5. And another 3/5. So that's -16 over 25 minus 9 over 25. So -25 over 25, so which is -1. All that work to determine that our answer was just little tiny -1. And here we go. We're done with the problem. Okay, let's do another example. Cosine of tan inverse of 4/3 plus cosine inverse of 12 over 13. So I want you to pause the video and try to solve this on your own. Now we're going to consider this is our alpha and this is going to be our beta. So pause it and try this. Okay, so did you use this formula? cosine of alpha plus beta. So it's cosine, so you're going to get cosine, cosine, and then sine, sine, and the middle sign is going to be negative. So let me just write it as cosine alpha, cosine beta minus sine alpha, sine beta. Okay, so let's apply that and see what we're going to get. So this is cosine of tan inverse of 4/3. Too many parentheses, huh? I hope you can follow this. And then cosine of beta minus sine of alpha and sine of beta. So again, it looks like we're going to have to work out this one. So let's take this downstairs and let's do the side work. Okay, so side work, oops. Okay, let's take a look at the first one. Okay, so I'm going to start off, let theta be tan inverse of 4/3. So that means tan of theta is 4/3, and theta is between negative pi over 2 to pi over 2. Picture time. Okay, so what do we got? We have tangent is positive 4/3, so better be in quad 1 or in quad 3. But do you see that since we're going to have to be between negative pi over 2 to pi over 2, quad 3 is out. So our angle theta is going to lie in quadrant 1. So tangent is opposite over adjacent, if you want to think of it in terms of a triangle. But let me just draw the triangle. So opposite, sorry, this is our angle theta right here. Opposite side is 4. This is completely drawn off the scale. And this is 3. That means hypotenuse must be 5. Okay, so I think we're good to go. So therefore, cosine of tan inverse of 4/3. This is cosine of theta value. Now, cosine is going to be positive in quadrant 1. So here, what we're going to get is cosine is adjacent over hype. So we're going to get 3/5. Now, those of you, if you want to work it in terms of x, y, and r, then this point right here is x is 3 and y is 4. And cosine is x over r. So it's still going to be 3/5. One down, 3 to go. So side work for circle 2. Okay, so let's just take a look at that. So okay, so we got cosine of theta to be 12 over 13, but theta better be between, oops, 0 and a pi. Okay, picture time. All right, now cosine is positive in quad 1 or in quad 4. However, since theta is between 0 to pi, do you see the quadrant 4 is going to be out, and our angle theta is going to lie in quadrant 1. So the cosine is adjacent over height, but regardless, let me just draw this triangle. So here, so adjacent side is 12, height is 13, so what's the missing length? 5. Alright, so I think we're good to go. So therefore, cosine inverse of 12 over 13. This is cosine of that angle theta. So cosine is positive, again, in quad 1, so your answer should be positive. Oh, sorry, those of you who like to use x, y, and r. So our x value is 12, y value is 5. Okay, so the cosine of theta is adjacent over height. And there you go. You know what? I think I just did extra work, but I guess we didn't have to do that because I just noticed it. So cosine of cosine inverse of x, this equals to x if x is between -1 and 1. So from off the bat, cosine of cosine inverse of 12 over 13 is going to equal to 12 over 13. So I'm so sorry if I made you work it, but hopefully you understand what we just did. Alright, so circle 3. We have sine of tan inverse of 4/3. So we're going to start off with the same way. So the tangent is what, negative pi over 2 to pi over 2. So let me just write it out. Okay, so picture time. Okay, so tangent of theta is positive in 1 and 3. But theta is between negative pi over 2 to pi over 2, so quad 3 is out. And again, our angle theta is going to lie in quadrant 1. So no matter what, our answer should be positive. So tangent is opposite over adjacent. So this is 4, 3. Well, we're going to get the same picture as circle 1 now. Do you see that? Alright, so anyways, sine of tan inverse of 4/3 is sine of theta. So sine of theta is opposite over height, so which is 4 over 5, or y over r, whichever you want to do is fine. So here it is. Okay, we can do this. One more, just one more. All right, circle 4 is sine of cosine inverse of 12 over 13. Okay, so that implies that, oh, and why is it tangent? Cosine of theta is 12 over 13, and theta is between, my goodness, 0 to pi. So that means what? We're going to get the same picture as circle 2, but let me just draw it out. So here's our triangles. You got 12, 13, and a 5. All right, so let's finish it off. So therefore, what are we trying to compute? Sine of cosine inverse of 12 over 13. This is sine of theta. So sine is opposite over height, so which is 5 over 13. So I think we're good to go. Putting it all together. So circle 1 is 3 over 5. 2 is 12 over 13. And minus circle 3 is 4 over 5. And circle 4 was 5 over 13. Alright, so we have 36 over, what is that, 65? Minus 20 over 65. So answer is 16 over 65. Phew! That was one problem, but we did it. Great job. Alright, so hopefully you were able to do this problem on your own. If not, just catch your mistakes. That's the most important part. Next example, we're going to be solving the equations now. So solve the equation on the interval 0 to 2 pi. So the equation is cotangent of theta plus cosecant of theta equals negative square root of 3. Okay, so in order to solve this, I usually don't like to deal with cotangent and cosecant. I'm pretty familiar with sines and cosines. So first what I'm going to do is convert everything in terms of sine and cosines. So let me just do that. So here you're going to have cotangent is cosine over sine. And cosecant is 1 over sine. Is negative square root of 3. So we can combine this into one fraction. Okay, now multiplying by sine theta on both sides, we're going to have cosine theta plus 1 equals negative square root of 3 and sine of theta. Now before I move on, let's look at this step right here. There's something very important. Notice that since sine of theta appears in the denominator, sine of theta cannot be 0. So let me just write that out. So provided that sine of theta does not equal to 0. Okay, so let's take a look at when the sign is going to assume 0. To me, it's a lot easier to just look at the graph, but you could do it whatever you like. So notice that sine, it's going to assume 0 at when theta equals to 0, theta equals to pi, theta equals to 2 pi. So that means what? Every multiples of pi, sine of theta is going to be 0. So that implies that theta cannot be the multiples of pi. So I'm just going to denote it as theta cannot be plus or minus k pi, where k is an integer. So let me just I'm going to have to use this later on. Alright, so let's move along. Alright, now it looks like we're pretty much stuck right here because I cannot do anything up to this point. But how about this? Let's square both sides. So that way we're going to have cosine squared and then maybe also the sine squared. And maybe we can play with that equation. So let me just square this. Okay, so that implies that this means what? Cosine of theta plus 1 times cosine of theta plus 1 equals, so here you're going to get positive 3 sine square of theta after you're squaring it. So let's multiply this out and we're going to have cosine square of theta plus 2 cosine of theta plus 1 equals 3 sine square of theta. Alright, so looking good. So maybe we can make it into a quadratic equation. So first, let's make everything in terms of cosine by using a Pythagorean identity. So I'm going to replace sine squared of theta by 1 minus cosine squared. So let me just write that out. Okay, so here what we're going to get now is what? Cosine squared of theta plus 2 cosine plus 1 equals 3, 1 minus cosine squared. Okay, so let's work this step by step by step. Okay, so now let's bring everybody on the left hand side and set the equation equals to 0. So what do we get? If I add 3 cosine squared of theta, we're going to have 4 cosine squared of theta, and then plus, that's a theta, 2 cosine of theta, and I'm going to subtract 3 from both sides. So here you're going to have negative 2 equals to 0. Alright, so let's make this a little bit simpler by, you can think of it as dividing out by 2's if you want, but this is equivalent to 2 cosine squared plus cosine minus 1 equals to 0. So now it looks like we have a quadratic equation. So I'm going to say let u be cosine of theta. So then I can rewrite this as 2u squared plus u minus 1 equals to 0. We can factor this. Which one has to have a minus? I think this works. Does that work? This one. That works. Okay, so let's keep going. So this implies that either 2u minus 1 is 0 or u plus 1 is 0, which means that u is positive 1/2, u is negative 1, but u was cosine of theta, and here you're going to have cosine of theta equals to negative 1. So let's go with the first one, cosine of theta equals to 1/2. So let me draw a picture. Cosine is positive, right? Okay, cosine is positive in 1 and 4. So here, adjacent side is 1, hypotenuse is 2. So here is 1. I don't know if you can see that, I'm sorry, 2, and that means square root of 3. So our theta is what? Pi over 60 degree pi over 3, or 5 pi over 3. Alright, so let me just write that out. So that implies that either theta is pi over 3 or 5 pi over 3. Okay, so let me just box that for now. We're still going to have to check our solutions, by the way. Alright, so now let's go on the other side. Now cosine of theta equals to negative 1. Remember, we're only talking about the theta between 0 to 2 pi. So it looks like only solution that we're going to get from this equation is theta equals to pi. Okay, now let me box that. Okay, so do you see the note that I made earlier? We determined that theta cannot be a multiple of pi. So what I'm talking about is over here. So guess what? Theta equals to pi is not going to be a solution. Okay, so now what we need to do is check if theta equals to pi third and theta equals to 5 pi over 3 are solutions. So let's take that maybe on the next page. Okay, so let me just write down the equation. So we had what? Cotan of theta plus cosecant of theta equals to negative square root of 3. Alright, so checking time. So let's check when theta equals pi over 3. So let's compute cotangent of pi over 3 plus cosecant, that's a cosecant of pi over 3. Is that going to equal to negative square root of 3? This is what you need to be asking. All right, so let me just compute this left-hand side. Okay, so cotangent is cosine over sine. And cosecant is 1 over sine. All right, just write that in big black equal sign. All right, so then cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. And here you're going to have 1 over root 3 over 2. So it looks like we're going to have what? 3 over 2 dividing by root 3 over 2. All I did was I just added the numerators together and kept the denominator as a common denominator. Now, this is going to be, let me just keep going on this side. So this is same thing as what? 3 over 2 multiplying by 2 over root 3. So this is 3 over root 3. But do you see that it's not going to be an answer because it's not going to equal to negative square root of 3, but let's just rationalize it. Just work it all the way. All right, so that does not equal to negative square root of 3. So therefore, theta equals to pi third is not a solution. Okay, we have one more hope. Let's check when theta is, which one was it? 5 pi over 3. Okay, we're going to do the same thing. Our left-hand side, I'm going to take the left-hand side. Oops, 5 pi over 3. All right, so now our job is to compute this. So let's get started. So cosine of 5 pi over 3. Let me just jot down the picture and determine where the 5 pi over 3 is going to lie in. So 5 pi over 3 is what? 5 times 60. So what is that? 300. So it's going to lie in quadrant 4. Alright, now cosine is positive in quadrant 4, but sine is negative, so keep that in mind. Okay, so cosine of 5 pi over 3 is same thing as cosine of pi over 3, so which is 1/2. And sine of 5 pi over 3 is same thing as negative sine of pi over 3. So it's negative root 3 over 2 plus 1 over negative root 3 over 2. So in this case, I think it's going to work out. So I will not skip any steps. So here we go. Rationalize. Yes, so which is precisely the right hand side. So therefore, theta equals 5 pi over 3 is a solution. Yes, yay. All right, so now let's write down the answer. So therefore, the only solution that we're going to get is solution set is going to be just the 5 pi over 3, and that is it. Okay, here we go. I know that this section involved many little tedious work to do just one problem, but hopefully you're still alive, and great job everyone, and I will be talking to you soon.